Greetings, my name is Ryan Nix. I'm a solutions architect with Amazon Web Services. Joining me here today is Eduardo. Eduardo, say hi.
Hello everyone, I'm a solutions architect with AWS as well. Nice to meet you all.
Now, we're going to take a couple of minutes and talk about resilience of OpenShift and potentially some IBM workloads running on top of OpenShift within AWS. And we're just going to highlight what happens when the wheels fall off as each component of the infrastructure fails, as it invariably will. One day it's going to break. What impact does it have on the application workload, and how much of a consideration is it from a resilience or a disaster recovery strategy? So let's start off very quickly by talking about what does OpenShift have as a resilience model. Now, this is a very, very common architecture. When we have a look at an OpenShift implementation on AWS, we're going to get a collection of EC2 instances, and I'm quickly going to draw out 3 distinct layers over here, and those layers are going to be duplicated across 3 availability zones. So immediately we've got the utilization of AWS's availability zone constructs here to protect us, that if something happens in this availability zone, I still have the other 2 availability zones servicing customers. These are all EC2 instances, and OpenShift will deploy an OpenShift control plane, and that control plane will be made up of 1, 2, 3 EC2 instances. These are commonly referred to as master nodes. That's the OpenShift API endpoint. It's all of the sort of Kubernetes pods that are OpenShift in itself. Then 1 layer down, we're again going to have a collection of EC2 instances, and this is the infrastructure node. Eduardo, you made a very valid point in a previous discussion that this is not always true. Sometimes we see these
Correct.
2 layers collapsed into a single layer. So this is a decision that a customer makes whether they want these separate or not. What's the benefit?
Yes, so if customers are doing an out-of-the-box installation of OpenShift Container Platform, these are by default merged together. So when you separate these 2 instance types, you get certain workloads moved from the master nodes into the infrastructure nodes, such as the OpenShift routing and name resolution, so that they can run, let's say, with less intensive workload on a single instance. And that gets you a performance benefit as well, and it also helps you with failure, right? So imagine if a single instance, when you collapse these 2 fail, you have more services being impacted. This way you're splitting things up.
So immediately there's a cost consideration over
Yes.
here. 3 EC2 instances versus 6 EC2 instances. I am provisioning more AWS infrastructure with this approach. But going this approach, the 2 big things for me is, 1, you mentioned blast radius. If I lose one of these or one of those in this design, I have a smaller blast radius. If I collapse those 2 together, I'm losing some of what is the control plane and some of what is the infrastructure layer. Most customers I work with make a conscious decision to separate these. The other element of this is in separating these, the scaling, the recovery of something such as a master node that's got etcd running on it is a very different ball game from how I would scale or how I would replace an infrastructure node. I could manually massage a new master node into an OpenShift environment in about 45 minutes to an hour. Infrastructure node, if it's just the infrastructure, I throw it away. I can have a new one in there in a couple of minutes. It's a different ball game. So a lot of customers make the conscious decision to separate these. Right, the other element that we have is over here we've got the compute layer. These are the worker nodes of OpenShift. These are the compute layer that's actually going to run my application workloads. So we do have the worker nodes over here, and we're going to see the application workloads. These would be Kubernetes pods essentially.
Correct. So Ryan, if we're talking about a customer that wants to move their existing FileNet installation into a new version of FileNet with IBM software on OpenShift, how would they do that here?
Okay, so hang on, for the benefits of some of the people listening, what is FileNet?
Right.
FileNet is an IBM software solution. It's largely a content management system. So if you think about customers such as financial institutions where there's a lot of documentation that's being signed and documented, they need to store the original document itself, a lot of metadata around that. They need to manage access to those documents. So it's a document storage repository. So I'm scanning physical documents, I'm storing documents as objects, there's a lot of photos, a lot of graphics, there's the related data to that, there's version control, there's approval processes. So there's a workflow mechanism in the background. There's a lot of very interesting little components, one of which is a tremendous amount of storage over here.
Yes.
The older versions of FileNet was, I would run it on top of a virtual machine with some storage sitting in the background. There's typically a relational database to manage the metadata associated with it, and there's some sort of shared storage environment or object storage. So on AWS, there's a couple of things here. We're probably going to see the likes of a relational database being RDS. I think let's put that over here very quickly. Wrong place. We're going to have a database and it will be, let's say, RDS. We would have AWS S3 sitting somewhere outside the VPC. Eduardo, can you pop in S3? And what I very commonly see with these implementations in their newer version is some sort of shared storage being facilitated by a typical Kubernetes shared storage platform. So your question was, old FileNet to the new platform is now bundled together with a cloud pack called Cloud Pack for Business Automation, CP for BA, if I had to shortcut it. It's not just FileNet, it's FileNet combined with several other IBM products into a containerized version that would run on top of OpenShift. So what we typically see supported with FileNet as well as the newer version of Cloud Pack for Business Automation is we would see what used to be called Red Hat's ODF or OpenShift Data Foundation. That's now being renamed to IBM Storage Fusion. Essentially, it's the same thing. It's a add-on component to OpenShift that is a storage layer. So you'll see storage nodes coming into the picture, and those storage nodes will have EBS storage attached to them in the different availability zones, and those will be presented to my OpenShift cluster. Now, a cloud pack like FileNet is actually very interesting because it's going to store any of the content management stuff, the documents that are scanned and uploaded. Those are typically go to an object storage here in S3. Right. The related metadata is also going to be stored externally inside a relational database, in our case, RDS. Yes. That could also be a containerized database. I have seen some customers deploy something like a DB2 environment, where relational DB2 runs as a containerized workload, and then it's going to use this storage layer in the back end. I'm not a huge fan of that. I prefer going to something like RDS. It's got native resilience built into it. If I'm scaling it up and down, if I'm dealing with the storage, I don't have to worry about an OpenShift administrative sort of context. But either which way would work. Yes. The other components of my Cloud Pack, and whether this is Cloud Pack for Business Automation or Cloud Pack for Data or Cloud Pack for Integration, it's largely irrelevant. They all have got components that require some form of persistent storage that needs to be shared. Correct. And we're going to see this sort of architecture. I want to break stuff. What happens if things fail? So let's talk about what could fail and what are the ramifications in the context of an application, and a complex application. I'm not talking like a little container. I'm talking about something that's got multiple containers that interact with each other, multiple microservices, multiple storage types. And let's start with the most common thing that could fail. Hard drives fail all of the time. Storage dies. A elastic block store volume, a hard drive that backs that technology could fail. And I'm happy to take this one at AWS as part of our EBS commitment. In the background of EBS, we don't write to one physical disk. We've got multiple physical disks that aggregate to form a volume. So when a customer takes this EBS volume and attaches it to an EC2 instance, they've actually got multiple physical disks. We detect that, AWS replace that disk, life carries on. So outside of some form of corruption in writing to the disk, or something where somebody accidentally deletes a disk, it's a relatively magical service. There's a lot going on in terms of resilience behind a volume failure. I've been working with AWS now for a decade. I have been incredibly lucky and I haven't encountered terribly many failed disks that had an impact on my business. You worked with a couple of customers in Europe on AWS as well. Is that something that keeps you awake at night?
Never had to be called in the middle of the night for something like this.
Right. That said, backups.
Yes.
This isn't a replacement for disaster recovery. Life happens, things can go badly. I am going to duplicate my data. I am going to make sure that data is available. So what we have, even if the disks are not really a concern, I am going to replicate that data to other AVs for performance perspective, so on and so forth.
And the other thing that I think it's important to know is that this data that Ryan's talking about here, this is application data, but the nodes also have their own EBS volumes attached to them.
So each of these EC2 instances, now that could have a bit of a ramification.
Yeah.
But more likely, I would expect the actual EC2 instance itself.
Yes.
Well, it's a virtual machine. What actually happens is the underlying physical hardware at AWS might run into a problem. I used to work in support previously, and we commonly had where something would happen, something would fail, and not one EC2 instance, but a collection of them. Multiple EC2 instances on an underlying physical host become impacted. And for a long time now, we've had the concept of design for failure. I know at some point in time, this EC2 instance is going to become unavailable, and that's where the concept of having other EC2 instances with the same function in a different AZ become available. So in a different AWS architecture, we might have something like AWS Autoscaling here.
Yes.
So Autoscaling would see here's an EC2 instance, it failed, it would destroy that EC2 instance and spin up a new one and replace it. Does OpenShift have a similar construct?
OpenShift has its own internal autoscaling mechanism, where you can define the number of worker nodes that you want on your architecture, and you can scale them in and out dynamically. So that's also possible.
This is the Kubernetes infrastructure autoscaler. Yes. Essentially, it will manifest as a machine pool.
Yes.
There's a catch-20 over here. That's not available at the control plane level.
Yes.
So there is no inherent auto-scaling mechanism for the OpenShift control plane. That said, you still have resilience. If this instance fails, the control plane will detect that failure, and it will then nominate one of the remaining master nodes to replace that function, and you have business continuity. However, you still have a failure that needs to be addressed. If this is something like self-managed OpenShift, where you're doing everything yourself, this is a human being that's going to get a notification, and they will have to go and spin up a new master node and massage it into the OpenShift environment.
Correct. Now, if you're using the managed version of OpenShift ROSA on AWS, then you have support from AWS and Red Hat behind the scenes to help you with those things.
Right, so a human being still does this. It's
correct.
Just not me.
It's just not you.
Okay,
yes.
So I'm not getting paged or called at 2 o'clock in the morning. In my experience, this is you get back to work and you get an email saying, hey, last night the wheels fell off and this is what we did to fix it. Have a wonderful day.
Correct.
I love managed OpenShift for that reason.
Yes.
That said, I've been working with OpenShift for just over 8 years now. I've encountered a master failure. Not a huge deal. Life carries on. The cluster sort of continues working, and you go through a well-documented process of replacing that. It's not the most fun experience, so I do appreciate somebody else doing it. But it's not something that happens every Tuesday.
Yeah.
This is not like in the early 90s where server infrastructure died every day and you ran around with 3 floppy disks with you to work every day knowing that you're going to replace a server. The other element here is, what if something else fails? If the master nodes fails, you lose a little bit of etcd, replace that, etcd replication comes back into the picture.
Yes.
Up. This is also not OpenShift 3. Back in the day of OpenShift 3, this was a painful process. With the shift to OpenShift 4 operator framework coming into the picture, this is a much more pleasant experience. The components of OpenShift are a lot more sort of self-healing, if you will. Infrastructure node, it's a router. It's a load balancer. It's how customers get to the application workloads.
Yes.
If that fails, you can't get to the apps. The rest of the infrastructure could potentially be dead. If we lose a router node, what are the implications?
Well, essentially you're going to have all the other nodes to handle the traffic and still access your application. So from a recovery point of view, you still have to go in there and recover this. But compared to the recovery of the master node, that's a more straightforward recovery because you don't have to deal with that CD data and anything like that.
All right, so much simpler to replace. There could be a very, very short-lived bump in the road.
Yeah.
You could have human interaction, so application connections coming through that router, and if that router node that is servicing that customer fails, you could see
those connections drop.
Those connections drop, and they would then be re-established through to here.
Yes.
So this has an impact on how you design the actual application workload, for example. How stateful is this application workload? What is the session information behind it? Again, not too bad. I'm not too worried about that. You don't have that auto-scaling mechanism, but you do have OpenShift resilience over here. When we get to the actual applications, there's a little bit of a different ballgame. There's a couple of things that could happen here. The actual application pod could fail, in which case Kubernetes puts on a superhero cape and comes rushing to the foreground, and Kubernetes will say, well, that pod failed, tear down the pod, launch a replacement pod, bring my workload back up and running. And that's why we love Kubernetes, or why we love orchestration mechanisms in general. Kubernetes is not the only thing out there that does this. We could lose an underlying EC2 instance that is a worker node. Big difference over here. The machine pools or the auto-scaling in OpenShift could detect and replace that. So here's where we see the first AWS or cloud-like replacement of infrastructure and workloads. There is a little bit of difference. The other thing is
that the pods that are here until this is recovered, they might get distributed to the other worker nodes so that you minimize the impact.
And that's another reason why we have them spread across availability zones, or we have them spread, I need 2, I'll have 3 potentially. So I don't take a performance knock in the event that something fails. From a storage perspective, the same thing could take place. I could lose a storage node. This is interesting because now there is the blast radius of the storage. Let's assume that nothing happens to the storage and I could replace the node, reattach the storage to that node, and I'm back up and running. Or if I do lose the node and the storage, I could re-provision the node, re-provision the storage, and then replicate from the other environment. Let's talk about something really ugly. What happens if something impacts my entire AWS availability zone? I suppose we should answer the question, what could actually result in that? Earthquakes, large-scale flooding. I've seen in Australia wildfires impact the temperature of data centers and overwhelm them. So, anything that could take out a physical data center, we assume could have an impact on an availability zone. And the idea here is that we have other availability zones far enough away that even though something nasty is happening here, it's not going to impact those other AZs. But at the same time, those AZs are close enough together that we don't see a performance degradation, shifting workloads to them. So again, immediately if this availability zone is impacted, we're not going to see the EC2 instances disappear. We might see people not being able to connect to them. Connection failures, name resolution at an ISP level. I have seen ISPs not being able to resolve things, and because of that, customers can't connect to a certain AZ. Networking issues at a TCP/IP routing layer where, in the back end of the network, something prevents customers from getting here. Large scale power outages potentially.
Yeah.
So AWS does try and protect against the vast majority of these, but you can't protect against everything. So when an availability zone fails, we'll see each of these failures happen almost simultaneously, and OpenShift will respond to each of them. The master node will shift to there, router layer will shift to there. Kubernetes will go through a bit of a hiccup over here, potentially move pods over there.
Yes.
We might, depending on the load on the underlying infrastructure, might see the machine pool kicking in and adding in nodes, and the storage caters over here. Eduardo, have you ever seen
full region failure?
Well, not just full region failure. Have you ever seen OpenShift fail catastrophically from end to end? Have you ever seen the entire OpenShift go down?
Never seen it.
I haven't either, and I've spoken to a couple of people from Red Hat. They've never encountered it. It is common to see bits and pieces of it fail, but I've never seen OpenShift holistically fail. I've been incredibly fortunate where I haven't seen a complete regional disaster. So what some customers ask me is, should I be preparing for a DR or disaster recovery strategy that is a multi-region approach? Personally, I wouldn't. I wouldn't start with that. I would start with a multi-AZ approach in a single region because of all of this resilience. And then if my business had specific requirements to go to a multi-region concept, then grow into that. Do that as a second phase. The other element over here is coming back to Cloud Pak for Business Automation, or coming back to something that has interactions with other storage mechanisms. S3 is hugely resilient. Or shall we say durable. It's got 11 nines durability in it because it replicates that data to so many different places. RDS, you could deploy it as a single AZ RDS and you don't get much resilience from that, but the assumption here is that RDS is going to be a multi-AZ RDS. So you essentially would have a EC2 instance and another EC2 instance, and if this one failed, it would then fail over to the other one and you'd get business continuity. But from a backup and restore perspective, backing up S3 is essentially copying the data out of it, storing it somewhere else, copying it back in. Backing up of the relational database, depending on the database engine, we could be talking about something like a dump of the data, but more realistically, it's going to be some sort of snapshot of that database. Or we could do a read replica to another location, and we could invert that read replica into a live database. From a ODF perspective, this is a backup of the storage, and again, this is potentially some sort of snapshotting and then sort of recovering ODF in there. From an OpenShift perspective...
Now what's important here is that from the snapshot, you would have to do cross-regional backups, right? So that imagine if you lose a region and you want to recover your cluster in another region, not only you need to bring the cluster back up, but you need to have access to the snapshots you've taken to recover the data.
Well, half a step back. If we're just talking DR, how to recover my business, I could do that in the same region, but I would typically do that into another environment. So I'd have two of these environments. I'd have non-production, I'd have production, and I'd be able to recover in the same region. But yes, if you did have a multi-region requirement, Eduardo is correct. You'd have all of this in the other region, and you'd need to make sure that you're replicating that data. That's the biggest problem here, is it's the data that is the big, scary thing. And replicating from one region to another is a different ballgame. I could be replicating from the east to the west of the United States, which is a very different ballgame if I'm replicating from the US to Europe. The latencies become a question mark as to how long does that take? How quickly does my data change, and can my data replication keep up with the churn of the data? From a Cloud Pak perspective, if we talk about complete and utter rebuild, we're talking about building out OpenShift on AWS first. Then building out the storage layer. Then installing the Cloud Pak
on top of it,
configuring the Cloud Pak, and then reintroducing all of the data components. I understand that this is important, but I'm going to rely in a day-to-day operational capacity much more on the resilience model than on defaulting to a recovery strategy.
Yes.
But you can't throw away the recovery strategy. You kind of
Right.
have to have both.
Yes.
So I think the big thing over here is twofold. Realistically understanding what could fail and what the ramifications are. It's not the age-old thing that if a single EC2 instance fails, that you're going to immediately divert to your DR strategy. You could be replacing a simple component, or at least a smaller component, of your overall architecture without having to do a complete backup restore or fail over to another region. For example, if I lose this EC2 instance, I would simply continue functioning on the other two.
Yes.
The resilience model of OpenShift and workloads running on OpenShift on AWS is actually very, very impactful. The possibility that something like a complex solution like this fails outright and you do need to go to a complete DR strategy does highlight a couple of things though. You do need to back up more than just one layer of storage. So understanding the storage decisions, how you back those up, how you bring those back into the picture. A couple of things at play here. I think AWS backup, the native service, would be very helpful over here.
Yes.
Things such as potentially Veeam, things such as Valero, which is a Kubernetes backup and recovery solution. IBM has a data protection product. Red Hat has a data protection product. There's a lot of options for customers to explore over here. But you need to understand the relationship of how these things fit together. This is not meant to be here is a silver bullet here. This is really meant to be, think about what you have built in your environment. Understand the relationships between the resilience model and the impact on your business, and apply some. I'm hoping that this is a thought-provoking discussion that you'll go away and think about, how does this relate to my business? What do my infrastructure, my application owning teams need to consider when they're building out solutions on OpenShift, on IBM solutions, on AWS?
Especially if you're coming from on-premises, really understanding what are your requirements for disaster recovery on-premise and how does that translate into AWS, because it doesn't necessarily mean that you have to go multi-region. In most cases, just going multi-AZ will be enough for you.
I mean, when I ran virtualization stacks on premises, I didn't have a myriad of services that were built with scaling, with resilience, with DR in mind. I didn't have the luxuries of an RDS. If I managed that on premises, I was dealing with, rebuild this, maybe bring a copy of the VM in, have to go through updates, have to start the data back in. It's a much more pleasant experience being on a cloud provider.
Yes.
Anyway, Eduardo, thank you. This has been a hugely fun and thoughtful discussion. It's always a pleasure having you here.
Thank you very much, Ryan, and thank you all.
Thank you.